Alright, so we're being recorded right now, just so you're aware. Okay, so we're going to take some notes on mostly linear functions. I'm going to move this out of the way. Mm-hmm. 25th? Is that right? Okay, so I don't know if you remember me saying this, but last chapter when we started memorizing the basic functions, I said then our next step now is we're going to kind of go through all of the basic functions and dig deeper. So linear, the parent linear function is y equals x, right? And the parent quadratic is y equals x squared. So really, in the beginning of chapter 2, that's what we're going to focus on. Okay, so these things are both considered polynomials. And I'm going to write the definition of a polynomial down, but that's kind of up to you if you want to write it down. It's also in your book. I'm going to really just point out some key features about what makes things a polynomial or not. Now, because this is general, it looks kind of messy. In general, a polynomial function has the form. I'm going to write a, and this is a subscript. Have you guys seen subscript notation before? So a sub n x to the n, and that's the nth power. And then a sub n minus 1 x to the n minus 1. And then I'm going to do plus dot 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 dot. What I'm doing here is when you're writing a polynomial function, we start with the highest degree and we work our way down to the smallest. So then I could get all the way to degree 2, which would be a sub 2 x squared. I'm going to run out of room. A sub 1 x to the first, but I don't normally write first. Okay, and then continue it down. I'm going to continue it down here. You probably have enough room. Plus a sub 0, and I don't even write x to the 0 because x to the 0 is just, what's anything to the 0? No, you guys don't know the 0 power property? What's anything to the 0 power? Not 0, 1. It represents 0 growth, and in multiplication, to show no growth, you have to multiply by a 1. Okay, so that's why anything to the 0. So I don't write x to the 0 there, it's just a sub 0. Alright, so what do all these things mean? So, let's first, I'm going to just write what those a sub 0, a sub 1, a sub 2, all of those things, those are just are real numbers. Okay, sorry about that, are real numbers. Also, we would never make a sub n equal 0 because what would happen then to that term? It would go, it would go away or be 0. So the leading coefficient has to be a number. So I'll write that down. A sub n is not equal to 0. Okay, so a sub n is what we call the leading coefficient. Okay, and then if you're noticing that when I'm talking about n, these powers, okay, these n values, n, n minus 1, and so on, they need to be integer powers. And they need to be non-negative. Okay, something you also need to understand is that every single function that can be written that will have some kind of constant and either an x or no x term can be written as a polynomial function. For instance, f of x equals 3x plus 2. That's, we know this is a line, right? This is a degree 1 polynomial because the first degree or the highest degree is 1. Does that make sense? A quadratic would be a degree 2 polynomial. Does anybody want to guess what this would be? That's a horizontal line. Okay, so this was x to the second, it's degree 2 when I listed it in order. This was x to the first, degree 1. What do you think? Any guesses? Degree 0, yeah. If I had to write something there, this is technically considered a polynomial, leading coefficient 7, but there's no, I mean I could write that, but we just talked about that, x to the 0 would be 1. So, just example of a couple things that you'll see. If you want to look at more of what is a polynomial, what is not, you can look in your book on page 163. But things you need to be careful of is like if I put negative powers, negative powers are not polynomials, or if I have irrational powers, things like that. If I have fraction powers, those are not integers. Okay, those are not polynomials either. Okay, I think you guys know how to do this, but I'm going to do one example with a linear function, and that is it. So these are polynomials. We're going to talk about linear and quadratic, and I am honestly not even going to give you notes on the quadratic because the only thing you're going to be asked to do on your homework is pick equations to graph, and you can use transformations like we learned last chapter to do that. Alright, so first of all, linear functions have something called slope or rate of change, right? So they come of the form f of x equals mx plus b, or our book writes it this way, ax plus b. A is, I don't really care if you write a or m. A is the slope. Do you guys remember what b is? Y-intercept. Okay. Really what I want you guys to be able to do is put something in point-slope form and solve it. That's how we're going to do linear functions. So I'm going to just show you point-slope form. Tell me if this is familiar. Y minus y1 equals m parentheses x minus x1. Does that look familiar to you? No? Kind of, sort of? Okay. So I'm going to do one example. Here's what we're going to do. We're going to take our 2 points that I'm going to give you. We're going to find the slope. We are going to then put the point and the slope into the formula to find our linear function. Okay. Find a linear function f such that f of negative 3 equals 5 and f of 6 equals negative 2. Now don't let that fool you. These are really just points written in function notation. Okay. So what ordered pair could I write for f of negative 3 equals 5? Yeah, this is the x, this is the y. So that's the same thing as negative 3, 5. So f of 6 is -2 would be the same as 6 -2. Alright, so I need to find the slope. Who remembers how to do that? Oh, come on. How do you find the slope with 2 points? y2 minus y1, or y1 minus y2, doesn't matter. On top, right? Remember, rise over run. I always tell my students, rise rhymes with y, so you remember to put the y's on top. All right, here we go. On top, I'm going to do -2 minus 5. On bottom, 6 minus -3. That gives me -7 over 9. There's my slope. Then, I'm going to put this now into point slope form. What do I know? What did we just find? M, right? And this x1, y1, this is just one of your points. You can pick either one. I am going to pick 6, -2. But you could pick the other one. Doesn't matter. So I'm going to pick this one. So what I do is I'm going to write y minus y1. So I'm going to write y minus my y coordinate, which is -2, equals slope, which is -7/9, x minus my x coordinate, x minus 6. If I would have used the other point, it would have been y minus 5 equals -7/9 x minus -3. Now you might ask me, well, how is that the same line? Yeah, it is, because if you would distribute, we're going to distribute. If you distribute both of them, you're going to get the same equation in the end. So, alright. Cool. I picked this one because it's a yucky fraction. So, we should be able to do that. These I can put over 1, right, if I wanted to. Over here I have y plus 2. We distribute. This is -7/9 x. We're good so far, right? And over here I have -7/9 times -6. Wouldn't that be plus 42/9? We okay so far? Can we reduce 42/9 if we wanted to? What is it? I just distributed. Sure, you want to call it 4 2/3? That's fine, or you can leave it as an improper fraction. What would happen if I subtracted 2 from both sides then? If I subtracted 2, isn't 4 2/3 minus 2, 2 2/3? Yes, okay, good. If you left this as an improper fraction, it would be 8/3. So, that's okay as well. Alright. So that is our function. I guess our last step would be we would replace that y with an f of x equals -7/9 x plus 2 2/3. What does that mean? That means that the y-intercept of that line, it hits at 2 2/3, and it's going down 7, 9 to the right each kind of every unit it moves over, or down 7/9 for every 1 unit. Okay.